This video will troubleshoot the condition where the engine does not turn over or crank when the key is turned to start.
This is very likely an electrical problem, so let's look at the wiring schematic. This schematic highlights the start circuit. Electricity flows from the battery to the starter motor through the switch posts of the starter solenoid relay. This is highlighted in red. To activate the starter solenoid relay, electricity flows from the battery to the key switch and then back to the activation post of the starter solenoid relay. This flow is highlighted in green.
Here is a starter relay. You can see that there are two main posts, which are the switched posts. These are normally disconnected or normally open, but when electricity is provided to the activation post, these switched posts become connected or closed. When no power is supplied to the activation post, the two switched posts are disconnected. This can be seen with a multimeter set on the continuity function. When voltage is supplied to the activation post, the two main posts become continuous. This can be seen here using a switch that allows power flow to the activation post. Note that some relays have two activation points, one of which receives a positive 12 volts, and the other goes to ground via a jumper wire. Other solenoids are single post. The single post receives the 12 volts, and the ground is taken from the solenoid bracket. Using a multimeter set on DC voltage, check that the battery is charged to 12 to 13.5 volts. If the battery is less than 12 volts, charge the battery overnight using a trickle charger. If after this the battery is still not charged to 12 volts, replace the battery. Visually confirm that the terminals are properly secured in the housing. To ensure that the starter solenoid is receiving voltage, check voltage between the bottom post of the solenoid and engine ground. On a machine that has two terminals on the starter solenoid, you should have continuity between engine ground and the topmost terminal on the solenoid.
On a machine that utilizes a single post solenoid, you should have continuity between engine ground and the solenoid bracket.
The upper starter solenoid post should be connected to the starter motor post. Use a multimeter to confirm connectivity. With key turned to start, you should see 12 volts between engine ground and the starter solenoid activation terminal. Furthermore, we should see significant voltage between this top post of the starter solenoid and engine ground when the key is turned to start.
If significant voltage was detected, but the engine did not turn, then the starter motor is faulty and needs to be replaced, or the engine is seized. If the activation post on the starter solenoid is receiving voltage, but the starter motor is not engaging, then the solenoid should be replaced. If the activation post on the solenoid is not receiving voltage, then continue watching.
Relative to machine ground, the red wire that is coming to the key switch from the engine wiring harness should be constantly energized with 12 volts. If the red wire is not receiving voltage, then the wire is either severed, disconnected, or the battery is not properly connected, as we've previously discussed.
Uninstall the key switch assembly to check function with a multimeter. With key in off position, you should have continuity between black and yellow wires. With key in run position, you should have continuity between white and green wires. With key held in start position, you should have continuity between white and red wires. If any of the 3 continuity checks fail, replace the key switch. It is extremely likely that one of these checks has revealed the issue. But if not, please do continuity checks with the battery disconnected and voltage checks with the battery connected across all components according to the wiring schematic to identify any loose connections or severed wires.